Let's now review the last section of our material that will be part of the final. So continuing object-oriented program, same example that we were looking at before. Let's assume now we have implemented a faculty, which are also inherited from person. So each display all is implemented different to handle the extended attributes for each class. So the faculty has a different one from the student, has a different one from the admin. We should be able to create one function that executes display all for any person, being that a faculty, a student, or admin. We want to write a code segment on main that declare an instance of each of the derived class from the person, then call display person function, which will then execute the appropriated display all method. So let's see this example for that. So over here we declare a pointer of each type. So there's a pointer, my perf as a person, my student, there's a student, my faculty for a faculty, and my admin for an admin. So what we do with that is we use the student pointer to create a new student, initialize the student. Then we do a sidecast, we convert the student pointer to a person pointer, so we can use the dynamic allocation of the virtual function. So with that, we can call this function called display person that will internally call the method display all, and then the correct display all for the student will be called at that time. We do the same thing for the faculty. We use the faculty pointer to be able to create a faculty, and with that we convert the faculty pointer to a person pointer, and then again we call the display function. You see internally here inside of the display person function we're passing a person pointer, and with that we execute the display all method inside using the person pointer. But since we created a student, that will be the student method that will be called. We create a faculty, that will be the faculty method that will be called, or the admin method. So let's look at one more example. Let's assume there is a non-default constructor that initializes all the values of the person. So we're going to declare a pointer of the base class, create an instance of the derived class, call the non-default construction, and invoke display all. So first we create a person pointer, my person. We create a student using my person. The problem is, as we do that, the person pointer can only see the attributes from the person point of view, not the student, because we're using a person pointer. Then we call the display all, but this is incomplete, and we discussed before the code was incomplete because we have the slicing problem. Since we're using a person pointer to create a student, we can access all the attributes and methods from the person plus any method that was virtual from the student. But the correct way to implement that would be we create a person pointer, we create a student pointer, use the student pointer like we showed before to create a student, then convert the pointer to a person, then call the function or using the display all method. Let's take a look at a few examples of virtual functions as we had discussed before. So you see here there's multiple implementations for the same speak function, one for the pet, which is the base class, and one for each derived class, the dog, the cat, and the mouse. So if we look at here the pet implementation, which is the base class, we have to have a virtual destructor because we have virtual functions. And then here we have this virtual speak, which will be replaced by a virtual speak in any of the derived class. Finish here with the attributes. So on the mouse, for instance, which is derived from the pet, again we have a virtual destructor and then we'll have a virtual speak, which will dynamically replace the virtual speak from the parent, which is the pet. So like we said before, because we have a virtual function, we also need a virtual destructor. And here's the different implementations, which the proper one we call when the object is created. So if we create a cat, then the cat will be executed. If we create a dog, the dog will be executed or binded. Here's an example for the main using that speak there. So we put all the include files there. Then in the main we create 4 pointers. They're all pet pointers that will be used to create the different animals. Here I create a pet using a pet pointer. Then I create a dog using a pet pointer. I create a cat using a pet pointer, and I create a mouse using a pet pointer. Those would be assigned to the proper display and speak function, in this case, or speak method. So you can see there that I initialize all the different parameters for the different types of animal, dog, cat, and mouse. Now when I call the speak or invoke the speak method, the proper method in each one of the different animal types will be used. Then I invoke the display, and I'm saying in order to do the dynamic binding, we needed to use pointers, and there were parent pointers creating objects that are derived objects. So here's the output. You notice that depending on the type of animal that we created, the proper speak method from that animal was invoked. So Buddy say woof woof, that was a pet. Bear say meow, that was a dog. Ben say squeak, that was the mouse, and Fluff is speaking. So let's look at another exercise here. So we want to determine which method will be called, assuming the two classes below here. There's a parent class, which has 3 methods: a method 1, a virtual method 2, and a method 3. And then child is derived from parent, and child has 2 methods, method 1 and a virtual method 2. So let's look at this implementation here. We want to be able to determine which appropriate method will be invoked or called once we execute this program. So we create 3 pointers. There's 2 parent pointers, ptrp1 and ptrp2, and a child pointer, ptr3. So then I create 3 dynamic objects. ptrp1 points to a parent object, ptrp2 points to a child object, and ptrc to a child object. So now we're going to figure out which of the methods listed there are the ones that are going to be invoked. So let's look into that. So the first one, like I said, create a parent object using a parent pointer. Second one creates a child object using parent pointer. And in this configuration, since I have a parent pointer pointing to a child, we would be able to see the dynamic binding happening. And then I have a child object using a child pointer. So let's look at the first case here. I have a parent object creating using a parent pointer. So there's only parents, there's no childs. So method 1 and 3, 2 and 3 here would be methods from the parent. So parent class method 1 is invoked, parent class method 2 is invoked, and parent class method 3 is invoked here. Now I'm using a parent pointer to point to a child object. In this case, because I have the virtual function, whichever virtual method exists, it would be accessed from the child. So ptr2 method 1, it's a parent pointer, so it's a parent method that will be seen here. So parent 1 on the parent. The second one, method 2, is going to be a virtual method 2 that would be invoked from the child. And then method 3 is only from the parent. Now the last one, I have a child being pointed by a child pointer. This is an example of a static binding. So all the methods there are from the child, unless the child doesn't have, then it will be the parent. So method 1 is from the child, method 2 is from the child, and method 3 will be from the parent, because the child doesn't have method 3. So let's look at an inheritance exercise to understand or to review the concept of access identifier. So here is a parent, and the parent has 3 groups of data. There's public data, so it has a method over there. There's a protected portion, there's another method there, and then the third one is a private, and there's another method there. So we inherit 3 classes, and then we use the identifier as public, protected, and private. So we have this child pub, child pro for the protected, and child private. So what we wanted to understand is what methods and objects can access based on those different types of access identifier the information from the parent. So I want you to list all the parent methods that can be accessed by the child pub, by the child pro, and by the child private. So recall that the relationship between the parent and the child is defined by the parent. It doesn't matter what the access identifier indicates. If a parent has either something public or protected, child methods, we will be able to access the information. So in the child pub, what can we see there? We can see public and protected. In the child pro, we can see public and protected. So it doesn't matter what type of the child is on the access identifier, we always going to be able to see public and protected. And private, again, public and protected. So now let's look at the list of all parent methods that can be accessed by objects of the following class. So those are objects. Recall the objects can only access things that are public. So on the child pub, what they would be able to see, they would be able to see anything is public, and that's the basic rule of objects, can see anything public. How about in the child pro? What's going to happen there? Anything that's public will become protected, anything that's protected is to protect anything. There is private still be private. So if whatever was public is now protected, within the child pro, no objects from the parent will be visible. No methods from the parent will be visible by an object. And if it's private, it's even worse, but none, again, public is now private. So let's continue looking here. Let's assume now that we derive a new class from the child class. We'll call them the grandchild. So in that case, what we wanted to find out is, from that grandchild point of view, what they can see on the parent. Parent derived child, child derived grandchild. So which parent methods can be accessed by these classes? So we're looking at parent methods that will be accessed by the other class when you were writing a method, for example. So class grandchild public would be able to see anything because it comes from this child public, anything that is public or protected, right? Because this is a method inside. How about if we go to the child pro? Child pro, what it's done is anything that was public came protect, protect still protect, and then private is private. So we'll still be able to see anything that's public, which is now protected and protected. The last one is what happened with methods now that we go to this child private, which is going to make everything private. Stuff that was public became private, stuff that was protected became private. So now we won't be able to access anything as public and protected are now private. Let's look at one more exercise here. So what we wanted to do is which parent methods can be accessed by objects of this class. Remember, objects can only see public. So what's going to happen here? So we have a child public. So anything that public, that would be able to see it, right? Now with child pro, anything that was public became protected. Anything that was protected, still protected. Anything that's private, still private. So now they won't be able to see anything because whatever is public is not protected. Finally, let's look at this grandchild. Now, the child priv is the private. So anything that was public or protected now became private. So again, objects won't be able to see anything because stuff that they could see what's public is now private. Let's take a quick look at recursion, what we learned. What is recursion? So it's defined as the process in which the result of each repetition is dependent on the result of the next repetition. So we're using function calls to approach us to a result. Every time we haven't found the answer yet, what we call the base case, we're going to call the same function again by simplifying the problem that's to be solved until we converge to the result. True or false? Every loop can be implemented recursively. Yeah, it is true. The other way around is not true, but any loop can be implemented recursively. So what are the advantages and disadvantages of recursion? The advantage is model certain algorithm much more accurate or most accurately. Results are shorter, simple functions. So usually you have a very small algorithm that's used recursively. The disadvantages may not execute very efficiently because function calls take some time because you have to save the context, create variables on the stack, initialize them, and so on. And last here, what is a base case? Base case was defined as a simple to solve problem as known the base case. So recursive functions will stop when the base case is reached and they'll start returning for whoever calls them.